So building off of Dalton's concepts, his major postulates, he developed the law of multiple proportions. So the idea is very, very simple, but actually realizing what he was talking about requires a little bit of a closer look. So John Dalton said, if two elements A and B combine to form more than one compound, the masses of B that can combine with a given mass of A are in the ratio of small whole numbers. Basically, what that statement really is talking about is that there are only certain steps that you can see in a molecular compound. So if you have, for example, carbon and oxygen, you can have 1 and 1, 1 and 2, 1 and 3, or 2 and 2, but no matter what happens, you have whole numbers. That's really what he's talking about, but he basically means that you can't have any half a mass of oxygen or carbon. So to emphasize really what we're looking at here, we have this particular situation. So we have two situations where methane is being burned. The top one looks at methane being burned under a complete combustion, and the bottom one looks at methane being burned under an incomplete combustion. So the top one produces CO2. So CO2, which is a nice little linear molecule. And then carbon monoxide is produced in the other one. Which forms a molecule very similar to that. So what we know for sure is that anytime we have carbon and oxygen combining, the mass comparison between carbon and oxygen needs to be maintained, or basically I have 16 grams, and 12 grams here. If I add another carbon, I can't add 6 grams, I'm going to have to add 12 grams. Similarly, in this particular case, I have 16 grams and 12 grams. And when I look at this particular compound, the fact is, again, if I want to add another oxygen, obviously it'll be the same as up here, but I would still have to have 16 more grams. So basically Dalton is just saying that in a compound with two elements, the ratio of oxygen or the ratio of their masses has to increase by whole numbers. So I've filled in a little table here, and one of them looks like carbon dioxide, and one of them is carbon monoxide, so compound 1 and compound 2. Carbon dioxide's formula weight is 44 grams per mole. Carbon monoxide's formula weight is at 28 grams per mole. Carbon has 12 grams. Oxygen has 32 grams. Again, 16 plus 16 gives me the 32. And down here we see 16 grams for oxygen and 12 grams for carbon. So the first thing that we are really going to look at is the mass of oxygen per 1 gram of carbon. In other words, I'm going to divide oxygen by carbon. So 32 divided by 12 gives me 2.67. And 16 divided by 12 gives me 1.33. Again, looking at both of these ideas, all this means is that for every 1 gram of carbon, I have to have 2.67 grams of oxygen in the molecule. For every 1 gram of oxygen, I must have 1.33 grams. So, kind of going backwards from this, I know I have 1 carbon and 1 oxygen. That means that I can only have the difference between this and this must be some ratio. Again, whole number. So visually this is very easy to see that this number is twice this number. In other words, there are twice as many oxygen in CO2 as there is in CO. What I would normally do if it wasn't obvious is I would divide this each of these numbers by the lowest mass per gram of carbon. In this case, 1.33. So 2.67 divided by 1.33 is effectively 2. 1.33 divided by 1.33 is 1. So there's twice the amount of oxygen in the first compound as there is in the second. So in any particular molecule or that has the same two components, like carbon dioxide, carbon monoxide, we should be able to do this. The explanation is very straightforward. That if you have only two compounds or only two elements, you can only increase the number or the mass of A compared to element B by a certain number. You can't do it by any fraction. I can't increase the mass ratio of oxygen to carbon by half of 1.33. It has to be 1.33. If it was CO3, we would expect this to be 3.99 or closer to 4. So we can only increase the ratio by whole numbers. That's all Dalton was really getting at. He simply wanted us to emphasize or wanted us to understand that an atom has a given mass, and as we change compounds with the same ingredients, like carbon and oxygen, we are just going to be able to adjust their masses by finite or definite units. In this case, the unit would be a unit of oxygen, would be the difference between the two.